Once you graph this, you're now ready to look at the limits. So the first limit here is the limit of f of x as x approaches 1 minus. That means I'm approaching the x equals 1 from the side of the negative numbers, from the left side. So as I approach 1 from here, where is my graph going? It looks like it's going up to what value? 3. The next one is the limit of f of x as x approaches 1 from the positive side. So from the positive side means I'm approaching this way. And again, imagine you're this person walking towards x equals 1, and you always have your eye on the graph. What does it look like the graph is doing? It looks like the graph is going down to y equals 3. Okay? What we see here is that the limit from the left side and the limit from the right side are the same. They're both 3. That means the limit here of f of x as x approaches 1 is equal to 3. Okay? So each of these is a one-sided limit. This is from the left side and the other one is from the right side. Now, I have the graphs for the other ones drawn here just to save some time. So this is what I was talking about before. The graphs here do not connect. So when you're graphing on the test or the quiz, this is 0.5x plus 2. If x is less than negative 2, you need to show me here that there is an open circle, and you need to show me here that there's a closed circle. Okay? In order to graph this one, you have to mentally put in negative 2 into this function. Okay? If you put negative 2 in here, you get negative 1 plus 2, x equals 1. Okay, so
1, you get 1. So negative 2 times negative 0.5 is 1.
Right, 1 plus 2 is 3, so this whole is at y equals 3. Okay?
That's an open circle.
Right. Okay, so let's see what the limits are in this case. The limit of g of x as x approaches negative 2 from the negative side, from the left side, right? As I approach negative 2 here, it looks like my graph is going down to y equals what? 3. 1, 2, 3. It looks like it's going to 3. From the other side, from the right side, as x approaches negative 2 from the right side of g of x, so as I approach negative 2 from here, what is my graph doing? It's going down to what value?
Negative 4.
Negative 4. Now, you can see here that the left-sided limit and the right-sided limit do not match. Therefore, the limit of g of x as x approaches negative 2 does not exist. In the next problem, we're looking at x equals 3, which is here. 1, 2, 3. All right, let's see our one-sided limits. The limit of x squared minus 4 over x minus 3 as x approaches 3 from the negative side. Right, so as I'm approaching here, what's happening? Where is the graph going? Down to negative infinity. From the opposite side, as I'm approaching negative 3 from here, where's the graph going now? Up to positive infinity. Therefore, the limit here does not exist. as x approaches 3. All right, let's see what happens here. So again, I put up my limits. This should say the limit of negative 2 over x to the 4. As x approaches 0 from the minus side, the limit of negative 2 over x to the 4 as x approaches 0 from the positive side. All right? So if I approach from the negative side, where is the graph intending to go? Negative infinity. From the positive side, where is the graph intending to go? Negative infinity. So what is the limit here as x approaches 0? Negative infinity.
Wait, why is it not infinity for the one up there, but it is here?
The one up there, from the left-sided limit is negative infinity. The right-sided limit is positive infinity.
Oh, they're not the same.
They're not the same value.
Never mind.
Here is a graph of the sine of 1 over x. This is not one you have seen before. The sine of 1 over x, I want to find the limit as x approaches 0. Okay?
Well, I mean, there's not
0 is here. So I want to approach 0 from the left side, and I want to approach 0 from the right side. As I come in closer and closer to 0, the graph will oscillate up and down very, very quickly, more and more quickly as I approach 0. So as I approach 0, do I know whether the graph is up at y equals 1 or down at y equals negative 1, or do I even know that it's somewhere in the middle? No, because it's oscillating so quickly. So the limit here does not exist. Okay? Because there is no way to guarantee for sure where the limit will be at x equals 0. Okay, where the value will be at x equals 0. Because it's oscillating at such a high frequency. Okay, here is a different one. Until now, we had been looking at limits as x approached a certain value. And when we do that, we always need to approach it from the left side, and we need to approach it from the right side. So we need to approach from 2 directions. Now, we're going to look at the limit as x approaches infinity. Okay? So imagine you're now on the x-axis and you're approaching infinity. This way. All right? If you approach infinity, as you approach infinity, there is no way to get to positive infinity from the other side in. All right? Because you don't know where infinity is. So you cannot approach it from the outer side. Therefore, when we're looking at x approaches infinity, we only approach it from the one side. Okay? In this case, we're approaching positive infinity. You could easily have been asked to find the limit as x approaches negative infinity, in which you follow the x-axis to the left side to negative infinity. All right, so here, as I'm here, again, follow that same analogy as, I'm here and I'm walking out here and I'm looking at the graph. I have my eye on the graph and I want to see what is the behavior of the graph. Where is it going vertically? Is it approaching a certain value? So as I approach positive infinity, what is happening to my graph? It looks like it's leveling off at negative 3. So the limit as x approaches positive infinity is negative 3.
Why'd you write that thing before the...
This is sine of x, and we're asked to find the limit as x approaches infinity. So again, we're here, and we're going to go follow this over to infinity. And as you're following to infinity, you have your eye on the graph, and you see it oscillating back and forth between +1 and -1. So once you get to this place called infinity, where is the y value of the graph going to be? Is it going to be at +1, -1, somewhere between? Where? There is no way for you to know, because you don't know specifically where infinity ends. Is this where infinity ends, or does it end immediately after? Because if you're even a millimeter away, then the value of the graph will change. So because we cannot pinpoint the location of infinity, there is no way for us to pinpoint where this is going to be. It's oscillating, it's fickle. So we say the limit, again, does not exist at infinity, because we cannot pinpoint a specific value towards which it will be heading. Okay? Yes?
Last chapter, did we consider this divergent or is this convergent?
Divergent.
Okay, cool.
This homework is due Tuesday, and it must be done on graph paper because you will need to graph in order to analyze the limits.